In machine learning, there is a special technique called zero-shot image classification. Unlike usual methods where a model learns from a specific examples to recognize certain images, zero-shot does something different. It doesn't just rely on what it has been explicitly trained on. Instead, it uses a kind of semantic understanding, reading into the context of the image and linking it with potential labels. So even if it hasn't seen a category during its training, this method can still make a confident guess. Let's see zero-shot in action. Here we have a picture of what looks like a tiger. We have given the system three possible labels: tiger, horse, and dog. Even without being specifically trained on these categories, the system confidently identifies it as a tiger with a high score of almost 100%, while the other options score very low. This showcases the power and accuracy of zero-shot classification. We start by bringing the tools we need. Here we are importing the pipeline. It is a function that sets the stage for us, making it easy to carry out complex tasks without starting from scratch. Then we set up our classifier. Using the pipeline function, we specify that we are diving into zero-shot image classification. We also tell it which model to use. In this case, it is Zenovac Lib VIT base patch 32. Now it's time to ask our classifier a question. We provide it with image of interest. Here it is a link to a tiger picture. We also curious to know how well it matches with the three labels: tiger, horse, and dog. Here is what our classifier thinks. It's pretty confident that the image is a tiger, giving it a score of close to 1. The other options, horse and dog, have significantly lower scores, meaning they are less likely. If you have a picture on your computer and it is not online, you can still use it. First, we turn the picture into a special link using url.createObjectURL of the file. This gives us a special link that our program can read. After we get this link, we pass it to our classifier. Now we come to the implementation. In our web page, we go to the computer vision category and we open the zero-shot image classification page. This page contains two subtasks. Now I'll go to Visual Studio Code and I open this file. Now the first thing we do in this file is, as usual, we create the script tag. We create it as a module or a type module because we want to use import inside it. Then we import the pipeline from the library URL, which we get from the Transformers.js official page. After that, we attach the pipeline function to the Windows object because variables inside a script of type module are scoped locally. And in order to be able to access our pipeline globally, I am attaching it to the window object. Now we go below to the initialize model. And in the initialize model, I define the classifier and launch the pipeline function in order to get me the classifier. Now the pipeline function takes the task, which is zero-shot image classification, and it takes the model name. Let me show you where I got this model from. So I'll copy it. I go to my web page, to the Transformers.js page, go to the pipeline API and go very below zero-shot image classification. Now if you go to models here, if I search, this is the model that I used. Okay, let's go back to the code. Of course, this method is asynchronous. It takes time, so that's why we use the await keyword, and the method is declared as async because we use the await keyword. Okay, let's get to the implementation of the first subtask. So the first thing we do is that we get the text input for the URL of the image, and we store it in text file value, and we get the labels. As you can see, the labels are comma separated strings, so tiger, comma horse, comma dog. So we pass the image URL and the labels. Then we read the labels and we trim them. We split them on the comment and we trim each of them, and that will return for us an array of these labels. So text field value contains the URL of the image, while labels is a JavaScript array with each string in the comma separated values that has been passed in this text input. Okay, then we fire the classifier, we give it the image and the labels. We store back the result in the result object. Of course, it takes some time, and so that's why we use the await and the async here. Let's now convert the result to string and output it to the output area. Let's go to the page, and now if we try to classify, you can see that it's classified it as a tiger 0.99%, as a horse very small, and as a dog very small. So the model was confident that this is a tiger. Okay, now what is if we have the file locally, we don't have the URL of it, so that still can be done. So I go back to Visual Studio Code. In the classify local image, I will first get the file input control from the page, and from it I will get the first selected file and store it in the file object. So the file object contains the first file selected in the file input. I then make sure that a file is selected, otherwise I alert and return. Then I use the URL object in order to create object URL from the file that returns the URL, which is a URL that we can use similar to an online URL. Of course, then we get the labels. It's exactly the same as above. We get the input text, we trim it, we split it on comma, and we trim each of them. So actually the URL now contains the URL of the local image, and the labels is a JavaScript array that contains the possible labels. Now I fire the classifier, I pass to it the URL and the labels. It's await because it takes some time, and the return value is stored in the result object. Now I just output this result object after converting it to a string and output it to the output area. Let's go and test it now. So I will choose a file, I will choose the tiger, and for the labels I leave it tiger, horse and dog. Let's classify now. As you can see, it classified it as tiger around 100% and around 0% for dog and horse.